In this example, we'll try to find the antiderivative of this given function here as 3 times square root of x on the first term, and on the second term we have 2 times cube root of x, right? So and there is a difference between these two functions, so our goal is to find the antiderivative of everything over here. But what we can do here is, as we know the some of the properties of the antiderivative or the integrals, we can actually just find the antiderivative of the first term, find the antiderivative of the second term, and then find the difference between those antiderivatives. So if that is the case, let's just focus on the first term here. But if you want to focus on the first term, there is actually 3, which is a constant, multiply by square root of x. So we can use the what rule? Constant multiple rule, right? So to find the antiderivative, which says, okay, if just find the antiderivative of square root of x and multiply by 3. But what is the antiderivative of square root of x? So as you know, there is no direct formula that deals with the radicals on the antiderivative, but the radicals can be changed into the exponent, right? So in general, if you have mth root of x to the power n, then this can be converted into the exponent as x to the power n over m, right? So or if you just have now square root of x, then how can you change square root of x? Means something like over here 2, something like 1, or let's say you know how to change the square root of x into the exponent. This is just x to the power 1/2. So that's how we could convert. So by using these transformation from radicals to the exponent, we can rewrite our problem as, so this is the integral sign, right? So that which means we are integrating, and then we have on the first term 3 times x to the power kind of what, 1/2, right? So for the square root of x, if you want to change it into the exponent, and then on the second term we have minus 2 times cube root of x, so something like by using that, so we have what, m is 3, n is 1, so 1/3, right? So then 2 times x to the power 1/3. So that's how we can convert the radical into the exponent. But so far we have not evaluated the integral. I'm just rewriting the problem, right, into an alternative form. But now let's focus on finding the antiderivative. Like I said earlier, just find the antiderivative of the first term, find the antiderivative of the second term, right? And then for the first term we have 3 times x to the power 1/2. So its antiderivative is whatever is the antiderivative of x to the power 1/2, multiply that with 3. So we'll have then 3 times, what is the antiderivative of x to the power 1/2? The antiderivative of x to the power 1/2 by the power rule, right? So we can figure that out, which is x to the power 1/2 right now over here, but add 1 on the power, so we have then 1/2 plus 1. But what is 1/2 plus 1? 1/2 plus 1 means what, 3/2, right? So we could write down here then 1/2 plus 1 is 3/2, so we could write that down. But not only that, we also need to multiply by the reciprocal of that 3/2 to the function. So reciprocal of 3/2 means what, 2/3, right? So then we need to multiply by that to the x to the power 3/2. So that is the antiderivative of x to the power 1/2, and we need to multiply that by 3. So that is, this is then the antiderivative of the first term. So do the same thing on the second term. So okay, we have minus sign, right? So on the second term we have 2 times x to the power 1/3. So we have 2 times antiderivative of the x to the power 1/3. So that's again by the power rule, its antiderivative is x to the power 1/3 plus 1. So what is 1/3 plus 1? So 1/3 plus 1 should be 4/3, right? So then we have then 4/3 is in the power, but again we need to also multiply by the reciprocal of that, which is 3/4 to the function. So we have 3/4 times x to the power 4/3 is the antiderivative of x to the power 1/3 multiplied by 2, right? And then plus, don't forget to add the general integration constant, and that should be it. This is the antiderivative. Here it seems like we can actually simplify further, right? So let's just try to do that. So which is over here on the first term I have 3 and 3 as a common factor. I can cancel that out. Here is 2, 4, I can cancel and then write down there 2. So if I simply work in that way, then on the first term I'll have 2 times x to the power 3/2, right? So that is the term. And on the second we have 3 over 2 times x to the power 4 over 3 plus c. So this is the required antiderivative. But if you like, you can convert again this exponent into the what radical form, right? So like on the first term we can change the exponent by again using this relationship. This can be converted into what, square root of x cube, or 2 over here, and then square root of x cube, but 2 is, this is something like again like the default, let's say, is 2. If we have that, we can just write down square root, right? So then we have x to the power 3 over 2 means square root of x cube, and on the second one we'll have 3 over 2. This can be written as what, cube root of x to the power 4. So by just applying again the same transformation, plus c. All right, or if you want to further actually rewrite it in an alternative form, square root of x cube means what, square root of x cube means something like x times x square, and then square root of x is square, right? So that is something like x. So we have then 2 times x square root of x, and then minus 3 over 2 cube root of x to the power 4 means something like cube root of x times x cube. So even with that, then we will have x times cube root of x. So we could also write down in that way, right? So over here, and then all right, so I don't know which one alternative form you needed, but this should be the one of the entire derivative of the given function.